Today we will be studying about graph analytics. Graph analytics are built on the mathematics of graph theory. Graph analytics basically help us to understand, codify, visualize relationships that exist between objects in a given domain context in order to uncover insights about the structures and patterns of the object relationship. So the important thing over here is that it is creation of or let's say representation of the data we have in the form of a graph, and then using that graph to understand the relationships that exist between the objects. Okay, so this is all about the networks and the connections we have between various objects we have. And then this helps us to uncover the insights, structures, and patterns that are hidden inside those object relationships. Okay? Now, because this is quite an important field and there is a lot of work that is done simply on understanding the relationship between objects, we have thus specialized graph databases. Okay. We did cover a little about them when we did the NoSQL parts. A graph database is again a part of the NoSQL family of data stores, which is optimized to store, model, and process data in graphical form. Okay. This is such a common use of data using the exploiting the relationships that we have a proper data model for that. Okay? And this graphical data model is stored in graphical databases such as Neo4j. Okay? And one of the good things is that it optimizes the query efficiency or the method means by which we query it. ठीक है वो जो ना सिर्फ ग्राफिकल मैनर में हमने उसको रिप्रेजेंट कर लिया, हमने उसको ऑप्टिमाइज भी कर दिया ग्राफ क्यूरीज के लिए. Next, let's see what we actually call a graph and what is not a graph. Now, at some time you may be confused that these are also called graphs, but technically these are not graphs, these are charts. Okay? Computer science की terms में, this is called a graph where you've got some nodes, some edges. The edges represent the relationship between these nodes, and there is some operation that connects these. Okay? So this may be the shortest path, this may be the highest path. So using something, we have these connections between these nodes. So a graph is an abstract data structure that represents set objects and their relationships as vertices and edges, and supports a number of graph-related operations. Okay. So graph nodes are the actual objects. They can contain a whole list of or a whole bunch of attributes themselves. The collections होती हैं. ठीक है, so they can be of maybe a huge number of sizes. MBs may even at times larger than that. These are can complete objects or entities in themselves, these nodes that I'm talking about. Then the edges and relationships, these can be unidirectional, these can be bidirectional, these can be from one node to the other only or from one to the other and back as well. Operations can again be of multiple types through which we form a logical connection between all of these. Example of some of the operations that the graphs have are like get nodes, get edges. Get nodes would get me all of the nodes there are. This is basically in order to create a list of the objects that I have. If I have all of the nodes, I have all of the objects that my graph contains. Then get edges. It gets me all of the relationships between the nodes, so I can get assign place demark any two nodes and get the edges between them, any two set of nodes. Okay? Then we can add nodes, we can add edges, we can add remove nodes. Okay? Shortest paths, we can get neighbors. Neighbors again, the network connectivity can be found very nicely by getting the graph neighbors, and we can also assign how many levels of neighbors do we need. Only the immediate ones, the ones that are directly connected, or also the one that are neighbors of the neighbors. Okay? Then we can get distance. Now this is the shortest distance between the two nodes. This can in some cases be the Euclidean distance. This can in some cases be the real world distance, where we check the cost between each of these nodes. Okay? So this is basically cost dependent, how we have defined the cost between the nodes. We can get the parents of any node. Given one node, we can get the parents of that node, all of the nodes on the higher level that are connected to this one are considered the parents. We can get again children. So all of the descendants of this node are considered the children of this node. We can get ancestors. The difference between parents and ancestors is the level on which it operates. Get parents would get you only the immediately connected nodes, whereas get ancestors would get you all of the connected nodes. So similarly, it is get descendants. Okay? You can even test that is ancestor to or is descendant to see if a particular node lies in the path or in the hierarchy of any other node at all. ठीक है तो एक नोड से हमने इसको कॉल कर लिया और दूसरी नोड हमने as a query दे दी, so it can tell us that anywhere before or prior to this node does it exist or does not exist. We can have add parents, add children, is reachable. So connectivity अगर आपने check करनी है between any two nodes, you can use the is reachable function. These are some of the most common operations that we can do on graphs. These are not all of the operations. There are some others that we can do as well. But these are the most frequently used. These not only build graphs, these are some of the basic theories of graphs as well. This is how we can easily initially extract data from graphs as well. Different languages may have a slightly different implementations of these, but this is generally a basic idea. So some of these are like graph operations that you can instantly do on the graph, complete entity. And some of these are the node operations. Given one node, what we can or cannot do with that particular node.